Okay. Not sure how to use the preview mode if I do video mute. Oh, that's cool. So you can't see it, and I could. Cool. Very cool. Oh, but people here online could see it anyhow, so it doesn't really help me. Um, okay, so let's start class 4. And let's see what we got here. So do we have any presentations today? So we have at least one. What? Yeah, well, okay, did you upload your presentation? Please, okay, let's just check. And then you're ready to go. Just please limit to, uh, let's see, upload your presentation here. Here we go. What's Wilson? Okay, say you. What?
Do I stay here or do I just step up?
Okay, whatever. So what you want to present?
Stay there?
Yeah, you just present over here so everybody, could hear you. And you're also being recorded, so I don't know. Where's Zoom? I think it's recorded. It should be showing your face, so. Okay, thank you.
So my presentation is on should a constructor be code free? Right?
Actually, could you try this? This is cool. Do you know how to turn it?
Nah, it's
There's a button. Uh, why not? There's no audio. I thought there's something here for system. Wasn't there something here for,
I've never seen this. Sorry.
uh, okay. I just thought there was maybe here. Oh, here it is, lectern. Here, turn it. Try.
That's
There you go.
so. What is a constructor? A constructor is a method in a class. Sorry, what?
Just speak regular, but.
Oh, okay. Okay.
Sorry.
A constructor is a method in a class that is automatically called when an object class is created. Right. So this is an example of a constructor for an object. It is so this one is it's creating a dog with a string name and its age, right? And then lower down we see that how the constructor takes in the data, which is this dot name and then this dot age, right? Then lower down we can see that when the new object is being created, it is given a name called Lola with a age of 3, and then it was it'll print out the my dog name is, and it will have the name, and then she is the 8 years old. Which is, common uses for a constructor is a linked list. So there's an example code for a linked list, and there's a basic image of what a linked list is, head of data and pointer points in next. It's also used in trees. Here's an example code for trees, and here's a basic image of what tree is in coding. And should a constructor be code free? I think not, because kind of need the data to create the objects or items we need. But I don't think it should be too clunky or have too much code, so too much unnecessary code, right? Just enough for what the object is needed for. And that's all.
Okay, anybody else? Very good. Short and sweet. Oh, you can hide it by clicking the top of the hide control. Yeah, you can hide the top control.
How do,
You just click over. Here is hide loading control.
okay.
I don't know how to promote here. Control Alt, whatever.
Okay.
Yeah, there you go. I have to remember the key file. There
So,
you go.
is there a way for me to make this full screen?
I think if you download it,
Okay, I'll just briefly download it then, and then. Oh, sorry. Let's see. Okay, I'll just leave it like this and just
yeah, that's it.
make it as big as possible.
There you
There
go.
go.
Good.
And then how do I add for this session? Okay, so this is my presentation. This is what are some ways to make database access faster, and I'm going to be mentioning 5 methods. So this is the presentation for CSCI 370 by me. Oops, sorry, I went too fast. So here are the 5 main methods that I will be explaining. First one will be indexing. So I'll describe what indexing is, the pros and cons. Then I'll be caching. Then I'll be discussing query optimization. Then I'll be talking about hardware optimization. And then finally, I'll be talking about data maintenance. So indexing. Indexing is the first one that we'll look at. Indexing basically is a data structure that speeds up data retrieval by setting up a data table for it's basically a lookup table for specific columns. And this is a lot faster because whenever new data is added, it gets basically placed in a specific type of formatted data, and then it's able to retrieve it more quickly because instead of reaching for all the possible data, you just have a smaller amount. And a widely used example of indexing is actually how the Google search engine used. And that's what made it a lot faster than the other search engines at the time. Obviously now, especially with AI, it's a lot more complex than that, but indexing was used a lot in the early days by Google so that whenever you look for a web page, it would just index the very specific keywords and then it would collect all of that and then put it into, and then it would separate it for each page, which would make it a lot faster to look up certain websites because Google would have already indexed all of those websites based on the keywords. However, though, the drawback of indexing is that you need to have extra overhead because every time you add new data or you update data, you also have to update basically like the indexing system. Because, for example, if there's a new website, Google has to store what the new keywords of that website are and then put it for the for the indexing tables for each of those keywords. So next one is caching.
So if you had a job interview,
Sorry.
someone asked you that it's a binary tree index, what would the speed be? This is totally one of experience. I'm just saying, like, this is a common question someone would ask you.
Would it be log n
Uh,
or binary tree?
it would be log of, it would be log of, and I think it's, like if there's a binary search is 2 to the
To
I
traverse
think you're
circle.
right.
Yeah.
Right.
For retrieval, right? For finding a specific
Yeah.
one, it would be,
It's really fast.
yeah. Oh, and that also helps through indexing, as you pointed out.
Yeah.
So the next method is caching. So caching is incredibly similar to indexing where it stores pre-computed data, but however, the difference is caching is storing queries that have already been ran. So for example, let's just say you have a database that like collects student information, and let's say you have student ID 1 and you want to get the grades of student ID 1. So you make the request for that. So the database will also cache the result of that. So let's say that student 1 got an A. So caching means that instead of the next time you ask for student one's grades, instead of it going back to the server, computing the information and then retrieving it, it'll just automatically give you the last data that was sent, which is an A. So that basically saves you time because it doesn't require the server to reprocess it. However, just like indexing, it also takes up extra space because you literally have to store that extra data. But it usually tends to be pretty important because it usually is small things that are repeatedly requested. So again, to save on computational resources, it's typically better to just store the actual query for it and then return it.
What could go wrong with caching?
That's exactly right. What could go wrong with caching?
Mhm.
So
Besides the speed.
besides the speed, well, spacing. Oh, and another thing is outdated data
Right.
is another thing. So actually, I'll go back to caching.
Yeah,
I mean, like because
that's a
outdated
big
data.
thing. Caching could be, have, a lot of times like I say, clear the cache, right?
Right.
Something doesn't work correctly.
So yeah, do you want me to further talk about it?
No.
Okay.
I just want to see if I can catch you.
So another thing that can increase the speed of database access is query optimizations. When I'm talking about query optimizations, it's basically little things in your SQL code that you can do to make your code more efficient. So for example, a very small thing that could make your code a lot more efficient is using the keyword exists instead of int. The only reason for that is something very small, which is just that exists terminates as soon as it finds an item, whereas in keeps going continuously until everything is looked through. Although that's a little thing for databases with millions of items, it ends up being very costly in the long run. Another thing too is that there's many other like little optimizations that you can do to make your SQL code more efficient. So for example, when you're using the where keyword in SQL, functions usually help a lot for you to get the data and for you to filter the data properly. But it is also very costly. So you need to be sure every time you use a function in SQL, you want to be sure to use it specifically when it's actually needed. And then there's other little things that I wrote down about like inner versus cross when joining tables, union instead of or, just because union takes also allows duplicates, whereas or filters out the duplicates, which ends up taking a little bit more processing power. But again, that when it comes to millions of items, that could make all the difference. So the next one is hardware optimization. So hardware optimization is sometimes just literally upgrading the hardware that you already have. So having more RAM and more random access memory would allow a lot more data for the server to cache or index, which would in turn make it faster for data retrieval. Faster CPU just means that the computer or server is able to process the data a lot more quickly, which also increases the speed for accessing data. Another thing is also the type of secondary storage that you use. So for example, if you're using a hard disk drive, it would be a lot slower than using a solid state drive. In that case, that would be a significant hardware optimization because the data would be way faster, it would be accessed way faster if you're using solid state drive than a hard disk drive. And the last one is data maintenance. Data maintenance basically just means checking through the existing data that you have within your database and to just make sure that all of it is correct and that it's like properly sorted and stored correctly. So for example, like there's 5 different ones here, but I'll start with data integrity. Data integrity is important because you basically just make sure that there's no corrupted data or there's no like different data types, like where if you want somewhere to have a string and it has an integer, then it would be wrong or vice versa. So data integrity is kind of manually checking through corrupt data and getting rid of it. Key integrity. So in SQL, we have both primary keys and foreign keys. And it's very important that both of them are connected because if you have a foreign key for a primary key that doesn't exist, that's kind of breaks the key integrity constraint. So therefore, that's another like data maintenance check that you would have to do. Backups. Although on the surface level, backups don't seem to make it faster. How it is very important because if you ever lose the data, then it will be way faster to get the previous data back. So although it doesn't physically make it faster to access the data, it does help it. It does make it faster to get all the old data back in an emergency situation. Fragmentation is another issue that can happen. This one is a little bit more abstract, but basically the more data that gets added to both caching and indexing systems, the more like that they can experience fragmentation because there's just so much data there that it just ends up being like a bit over flooded, especially when you have millions and millions and millions of data. You kind of really have to make sure that it's like correct in the correct spot. And this is like another issue with the modern day, like LLMs. Sometimes they just have too much text data, and that can at times make them less efficient because they end up taking bad data because of too much like text data. It's harder for them to filter through it. The last one is redundancies, just removing duplicates. It happens. Sometimes there's bugs that causes like an entry to be added twice. But that's still when it could like when you get into the millions of data, that ends up taking a lot of space. And then, yeah, thank you.
Yeah. I think also for indexing, if sometimes there's too much, it doesn't have time to reorganize the index.
Oh, yes.
To rebuild it. So when you rebuild it, it takes time. So like you do it at night, maybe.
Oh, yeah, that's
Yeah,
true.
stuff like that. Okay, great. Very
Thanks,
good.
Fred.
Thank you. Okay. Uh, okay. So I'll put, your grades on, I'll put it, probably by tomorrow. Um, on Brightspace. Okay, let me just switch glasses. Hey, I don't wear bifocals, so I just switch glasses. Okay, so so we're doing today class 4. So I wanted to go through inheritance, okay, and why it's not a good idea. Okay, first, so let's just look at because maybe you guys or some of you haven't looked at it in a while. So um, let's look at Java's, let's see. Let's see how, oh no, I'm doing the wrong folder. Okay, so let's just look at inheritance and we'll, a quick overview, and then we'll, and then, so this is some, everything we do in class I upload, so don't worry about a copy of it, but you should understand it. Okay, so this is a simple project, um, very, very simple, as you'll see. And just wanted to go over the basics of inheritance and the limitations of inheritance, okay? So over here we have a class A, which is a method, a bunch of, 3 separate methods that don't do anything. Then we have class B, which have a bunch of methods. I'm not sure why this one is not, oh, it's never used. Okay, that's so cool. And then we have class C, which has three methods, which I just put a little code in there. Okay, so, and then we have D, okay, which, okay, so now let's say we're using inheritance, right? So what, okay, so now the way you inherit is, basically you use the word extend, right? And in Java, in C sharp, and most of the other ones you just do, I think you do a colon, right? You do like, you would do, I think, I forgot the exact syntax. You do something like that, I think. Anyhow, but in Java, you use the word extend, okay? So extend means you inherit. So that means whatever, basically, there's 2 types of relationships. Actually, maybe open up this document. I have a document over here. Hold on. Okay. So there's 2 types of relationships that okay. Okay, so one, there's is a relationship. Um, and there's a has a relationship. Okay, so a is a relationship is that, for example, so the it's either just say an example. For example, if in our example, D is inheriting um, so for example, if we have So if we have class D extends C, right, what does that mean? It means that everything in C is in D. So it's a has, right? So in other words, like by people, when we inherit from our parents, we only get like half of from each or whatever the random stuff happens, right? The genes, right? But we don't get everything. But in Java or in object-oriented programming, when you inherit, you get everything from the parent, right? So that's why it's called is a. So that means that everything in C is also is now is now in D, class D, right? So, okay, you get that? So that's a very important idea. So when you inherit, you're not just, a casual relationship, but you actually are that thing, right? So in fact, for example, um, going back to this example where D extends C, right? So D is really also C, right? So in fact, it's so strong that we could write something like this. So we could example write C, um, which is class, I'll just do class C, is equal to new class D. So because D contains C, so we could actually have C point to D, right? Because D has C in it and other stuff, right? So, but we could have a pointer or a reference of C to D, even though, right? But could we do it the other way around? Could we do this? Could we do D? Could we do this? Could we do D class D equals to C? Well, this obviously we could do, right? That, right, we having a pointer of type D to, a reference to type D to an object of D. But what about this? Could we do this? Could we have D point to, I'll just call it DD because I don't want to, I don't, I want to keep it simple. And could this work? And the answer is no, because over here, D is a child of C, so it can have more things than C, right? It has its own stuff, right? So therefore, this you can't do, right? So this will not work because D uh, may have um, more uh, code or whatever. What do you say? Yeah, attributes, methods, right? I would just say more stuff than C, right? It could have more different, right? So, and we're going to see in a second what it could have different. Very good though. Yeah, I like the word you used, attributes. So, so over here, D inherits from C, right? Because it wants to reuse whatever C has, which is these two things, or three things, right? But do you remember how they taught, they probably taught you, how do you, when you inherit something, if you don't want that behavior, right? So then you could override it, right? So in Java, it's really simple to override it. Some languages, we have to make it, uh, there's virtual, there's all that other thing. We're not getting into that. Right? In Java, it's very simple. You just write another method with the same name, and bingo, the method got lost, right? So, so now in D, we're going to override, even though, so basically over here, why did we inherit from C? Basically, because we just wanted to use method C method one. The other two methods, we want to we want to override it, right? We want to have a different way of doing it. So what do we really gain by inheriting? Well, it seems like a lot of work. Um, well, because we really just wanted one method, but in order to get hold of that one method, what do we have to do? We have to inherit the whole thing, and then we have to override it or something else, right? Or we could, just leave a blank method to get rid, so we don't have the method from the one that's already in C, right? If we want to get rid of C method two, we just declare it in D and that gets rid of it. Does that make sense? So going back, let's just go back to main to make sure it's clear, because this is kind of important, because we're going to do a lot of examples of inheritance and stuff like that. So, so here, if we would do C dot C, which two, right? Class C, and we would, oh, oh, it's upper C. It's case sensitive. And if I would do, um, well, we're going to get different results, right? Because with uh, oh, okay, let's fix that. Okay. By the way, the convention I'm using is the basic convention that's used by Java. I think it's called camel case. So where you start lower, and then the next, the second word is uppercase, and you go back and forth. So for example, and the way you could see it is, let's say you go, for example, in D, if you look at the actual code, you could see it. So you see that the type, the class name is uppercase, and then the method, everything else is, basically everything else is going to be lowercase. Why is this? This should really be uppercase L. I don't know why they kept it lowercase, but I would think it, right, but if you look over here, you'll see that, see, this is lowercase, and here we see the first word is lower, and then the beginning of the second word is uppercase, right? So that's how they do it, right? Different languages have different ways of doing it. In C sharp, they do stuff with usually with uppercase. Everything is uppercase. The first letter of every word is uppercase. But in Java, the normal way of doing things is lowercase, except for types, which is uppercase. The first letter of every word is uppercase. So it's easy to tell by look. What did I just do? I just closed something. I don't know what. Oh, so yeah, anyhow, so this is the right way of doing it. Um, so if we would run this, you'll see that we can get different results because in D, right, we overrode the method, right? Oh, actually, it won't, it won't. Let me just, that's not a good example. Let's do C. uh, class C, um, object, I don't know, C object, something like this. Because actually this would be the same. Okay, so this is going to be different. So, and I just, okay. So over here, if I would do this, and I would do method 2. Okay, so we have, so over here we're pointing to really D, and over here we're pointing to D. So these are really going to give us the same, actually, I'm not sure what's going to happen over here. It's pointing to D, but it doesn't know about D. Well, let's see what happens. I'm not sure. But over here, it's definitely going to give us a different value because over here it's pointing to C. Okay. So I'm not sure what's going to happen over here actually. In C++, it makes a difference whether you declared it virtual or not. But I don't think, I think it's over here, it's going to override it. Let's see. Oh boy. Oh, it didn't like method Q. I wanted, what? Uh, what doesn't look like? Oh, public class. See, um, I'm trying to see. Looks like it's one extra, right? Okay, let's try that again. Okay, so you see that the, okay, so actually the first two were the same. And then over here, the one that's pointing to C is doing the one that's inside C. And these two, they're pointing to D, are actually doing something different, right? So they overrode, even though it's the same method, right? See, right? But when you inherit, when you override it, then you could do something else. Okay? So that's the basic idea. Okay, so that's one idea. So that is a relationship. Now let's try something else. Let's do a, I'll make this a little bigger, sorry about that. Has a relationship. So what this means is that like for example, I have a twin. So for example, um, like so basically you have a relationship with the different objects, but you're not the actual object. So I'll give you an example. It's actually class, where was that? D? No, I think it was um, one of these. Yeah. So for example, over here, I'm just gonna, do um, the bare minimum. So over here, so so has a relationship means that one object um, contains is contained in another object. I'm sorry? Yeah, that's has a, right? So it has, so for example, one object contains, very good. So uh, for example, below um, class DD has three objects, right? A, actually, little a, or B, or actually, well, let's just do uppercase, but it doesn't make a difference. B and then C. Okay? So this is typically called composition. So you have inheritance and composition. So these are the two main relationships between two objects. Okay? In other words, right? In other words, if you think about it, there aren't in programming, how do two objects communicate, right? There aren't too many ways for objects to communicate. So either you inherit from it, or you have that object inside of you. What would be the third way? It's typically where, I'm sorry, this is typically, this is called, typically called composition. What would the other way an object could relate to each other? So think about it, right? If you're writing a program and one object is communicating with another object, how many different ways are there? Well, we could inherit, we could have the object inside of you, or what would be a third way? Composition. Because you understand what, by the way, you understand why it's called composition? Because the DD in this example is composed, right? It's part of it. It's like, like a person's composed of skin, bones, muscles, blood, whatever. So this object is composed, parts of it are different objects, right? So we call that composition. So has a relationship. Okay. Then there's one more that I think I could think of another one maybe. I don't know, does anybody have a idea? Actually nowadays actually it's more common. But let's do the third common way, which is you have a reference to the object. So in other words, it's not inside of you, but it's passed to you, right? Like as a parameter. So you have I don't know what it's not, is it or has a, it's a, it's a, it's, I don't know it doesn't fit into the terminology of is a, has a, but that's the third way. So I'll just write that down. So, yeah, okay, different ways objects can speak to each other or can communicate, right? So one way is a relationship, so this would be one. The second way would be has a relationship, and the third way would be if you have a reference, meaning you like it's passed. Typically, it means it's passed as a parameter, so it's not in you, but it's passed to you, so you have access to it. A reference is passed to your object. Any other ways that two objects could communicate? Well, think about what is like, for example, let's say you want you have your credit card processed. How's that working? Like you're on your browser and you take money out of your bank or something like that, right? So what's going on? What type of relationship do you have? Yes, you're using I'm sorry?
Client server.
Your
Client server.
Right. But what type of, how are they communicating? How the client, right, so it's not by any of these three, right? Well, sort of three, but it doesn't have to even be that. Sometimes you have like a stub of of this, right, of the web service, right? But just basically you're just sending messages, right? You send a message, a request, and you get a response, right? So this is the only ways I know. So that this messages, through messages. Like typically the Windows, people don't realize it, but like the original Windows programming was a bunch of messages. So basically it still is. I mean, under the hood, basically there's like a message loop in the program, and the program gets different messages, and that's really how things work. And then, but it's all hidden by nowadays they have code that hides all this stuff. But underneath it, there's like every program has like a little message loop. And when it gets, let's say, a message, like for example, if I do a keystroke, the program gets a message that I hit the keystroke. So there's no, there's no is a, has a, or reference. It just gets a message that keystroke C press, and then the word program puts, will put out, if it wants to, will type the word C. So that'd be the third way. I don't know of any other way. Uh, there might be through messages. Um, okay, so this is a pretty thorough way, but if you think about it, there aren't too many ways that objects could communicate, right? Um, and we're going to actually do, when we do the UML, we're going to do 3 out of 4. We're going to do these 3, okay? Um, we're going to show how to diagram that, okay? Um, So I like calling a web service. Oh, this is, um, this, I should put this over here. Okay. Okay, now that's more clear. Get rid of 3. Okay, i.e. calling a web service. Okay. So, um, okay, so going back over here, so this is an example of composition, right? So over here, um, this object is able to use A, B, or C, right? Because it has composition. Now, but if we're using inheritance, right? Look over here. We're using, where was it? D. If you look over here, right, we can only use, oh yeah, one thing is in Java, you can only inherit from one object, right? So because of that, at a time, right? Does anybody know why they have that limitation in Java? Well, how come we can only inherit from one object at a time? It's, well, if you ever studied the other way of doing it, it's very confusing, right? Because let's say you inherit from 2 objects and they have the same method name, right? It gets very confusing, right? So Java said, we don't want that, right? We can only inherit from one object. In C++, I've never done it, but you could inherit from 2 objects, right? So, okay, did anybody ever try, did anybody know anything about other languages? Let's say Python, does that allow multiple inherit? Anybody know? But I've never used Python, so uh, I don't know about other languages. But Java does not allow it for a simple reason, because it just makes everything very complicated, right? Because then you have same method, 2 different objects. Which one are you using? It's not clear. Right over here, you can only inherit. But the downside of the way Java does it is, so for example, in D, if I'm using inheritance, what I'm limited to only, let's say I want to inherit, I want D to do some things that are in C and some things that are in B. Well, how do I do that? through inheritance, it's impossible to do it, right? There's no way that D could inherit from two things. So if D wants to do two things, it's out of luck, right? Okay, so that's one problem. Does everybody get that? Right? Because you can only inherit from one thing, right? Then because of that, you're limited. You sort of like by using inheritance alone, right? You're limiting yourself to only using, you're limiting your options, right? But over here, where we use composition, look at that. Where I have A inside of me and B inside of me, I'm not inheriting, but there I have them I'm doing composition. Over here, I have a choice of which object I want to use. I could use all three, right? You already see a big improvement, right? So this is one example where it shows you that composition is better than inheritance, right? Because over here, I could use three different classes within my um, within one class. So DD is able to use A, B, or C, right? While poor little D over here could only use C because it's doing inheritance, right? This is one example where composition is better than inheritance. I think I wrote that down. I just, okay. So that's number two, right? So I'll just copy the code here so it's easy to keep track of this. So I'll just copy that. I want to copy as plain text and then I'll put it in here. Okay. Um, the code below, class DD can access three different classes, right? Big improvement, okay? Okay, so that would be one improvement. Now, I like now that their book I mentioned in the syllabus is called Head Start. It does design patterns. So they have a famous example. I was actually going to use a different example, but they have they actually I think I have it here. So let's open this up. And they have a famous example called the duck example. So you can actually Google it. It's actually pretty well known. It's a very good example. I was trying to think of a better example, like from where I work, where I have problems with inheritance, and uh, and I do have problems, but it's hard to do it. But like if you Google the duck strategy pattern, you'll see this is from the book. It's a really good example. So over here, it's actually only part of the book. Um, okay. Um, so I want to go through this. Okay. So, so if we look over here, um, oh, I reopened that up. Where would that be? Hold on. Oh, this would be it. Let me just see what's here. Uh, yeah, this would be it. Okay. So going back here. Okay. So let's look at the duck. Okay. Famous duck pattern. The duck problem. Okay. And let's see. It's a funny book, by the way, in case you ever want to read it. It's like one of those books that's not that dry. So it's called Head First. It's an excellent book. And it might be a little too complicated for you know, I think they overcomplicate things a little bit, but they do, but at least it's very well, everything is very well explained, a lot of diagrams and pictures and stuff like that. So, um, so over here, let's say, um, okay, so let's say this is oh, this is the solution. Um, okay, let me make a new project. I'll just do the problem first. Uh, oh, I should have done that. Okay, so, and I'll try to do it quickly. I don't want to spend a lot of time writing code. Um, but let's see if we could see the problem with inheritance, okay? Okay, okay, so come on. We'll call this software engineering duck uh, strategy pattern. Okay, okay, so something doesn't look good. I already have that. I think I already have that. Oops, let's do it again. New project duck strategy pattern well 25. Okay. 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 So oh, okay, so over here, let's say we have okay, let's say we want to have a duck and we want to give it some things, so we'll have the duck do two things, okay? So duck, let's say, will fly and quack. Okay, so public. Does everybody know what quack is? Quack means like quack quack, makes the noise it makes, right? So we'll have um what's wrong over here? What did I do wrong? Why is everything red? Without without looking at the answer. Right. I forgot to, you have to do a return type, right? Right. In C++, what's the default return type for a method? If you don't, I think you're allowed to leave it out. When I remember, it's an integer, right? If you don't say type, I think it's an int. I'm not sure, but I seem to remember very clearly that that's what it is, but it's been a long time since I've done C++. Anyhow, so in Java, you have to give a return type. So, and so we're going to have fly, and print line is going to say, I am flying. No, regular flying, regular uh, flying. And then over here, it's going to be quack, and it's going to be, okay. So regular quacking. And then let's say now we want to, okay, then we have a bright idea. Wait, so you say, and then there's other things that ducks do, right? Other stuff that ducks do. I don't know, they uh, eat, I don't know, they think, I don't know what else they do. Okay, whatever they do, etc. Right? So, we're just concentrating on these two things. They fly and they quack. Okay? Then we also want to have a new class. Then our boss says, wait a second, we want, let's say we're a company and we sell ducks. So then the boss says, you know what? we want to sell a rubber duck, not a real duck. So we want to do, let's say, a rubber duck. Um, Rubber duck. And this is going to inherit from duck, right? But wait a second, a rubber duck doesn't really quack. What does it do? It has to, um, it squeaks, right? So we're going to have to override that. So we have to change that, which is, okay, which is going to be squeaking, squeak. And then, okay, and then the boss says, well, we also are going to have, let's say, a, um, a bath duck, right? What's that called? Um, no, that would be no, wind-up duck, right? Duck. Now, a wind-up duck is also going to inherit from duck. Actually, a wind-up duck, let's say, okay, yeah, so this is also going to inherit from duck, but what does it do differently? It, it does, it does the flying, it doesn't fly, right? So we have to, um, take out the flying for it, right? So we're going to say, take that out. We're going to say, I don't fly, okay? Uh, Wind up duck, I roll, whatever. Okay, now let's say we want to have a, a rubber duck that also, um, let's say we want to have a rubber duck we want to have we want to have a duck that acts like the rubber duck, but it also, uh, but instead of, let's say a wind up squeaky duck, right? So, or whatever it is, you understand. So now when you have something that does some of what this one does and some of this one does, right? So we won't be able to, right? Because we said that already, right? And also, um, so we cannot do, so, okay, so basically the idea is that after a while, we just keep on having more things, but we can't really reuse, all the things because, um, okay, let's say for example, um, let me do one more example. So let's say, wind up duck, oh, this one also, right, the rubber duck squeaks, right? And, also doesn't fly, right? Okay, so, okay, but let's say I want to have a rubber duck that, that swim, that doesn't quack, a silent rubber duck, right? Uh, so then, I have to inherit from rubber duck, and, uh, I have to get rid of the quacking. So, um, okay, I don't want to go through the whole thing, but the point is that, um, point, and this, I just want to get rid of the quacking. So the point is that when with it, let me do one more example with it. So we have the wind-up duck. We have oh, I'll do one more. So let's say we have a battery duck. And to the battery duck, let's say it void so I roll using batteries. And also, actually, let me change it. So extends duck. No, extends gets complicated. I don't even know anymore what to extend from. But let's say extends duck. And then also it happens to, let's say it's a red, a blue. So let's say for display. Okay, so show a blue duck. Okay, so the point is that now, what is the problem? That should be declared. Oh, I have to rename the file. Very, very picky job. Okay, so over here, if I want to reuse this battery ability, right, I'm also going to get this display ability also with it. And so besides the fact that we're looking at all these different objects that we've been creating, right, what's been going on is that if I keep on using inheritance, I have to get everything that comes. So now, from now on, whenever I want to use, let's say, a rubber duck, I'm going to get this type of squeaking and this type of not flying, right? That comes with it. And after a while, this whole thing sort of gets really, really complicated. And you can't actually, so for example, over here with the blue, I can't really reuse it unless let's say I have a red duck, I'm going to have to override the blue duck, right? So basically the idea of it is inherent that you get too much, right? You get more than you want to, right? So the question is there a better way of doing this? Okay, and the answer is yes. And the better way of doing, so again, what are the problems? One is we're creating, every time we do a different behavior, or a different combination behavior, right, we're doing another object. That's one problem. So we're having a lot of extra objects, and it's very confusing about what all they do. And number two is that we can't reuse just the parts that we want. We have to get the whole thing. Okay, so that's what basically the point of this duck thing. As you can see, it gets very complicated, and also if I want to reuse only part of it, I can't do that. I have to reuse. I have to so if I want to use the battery, I have to use the blue duck now. Okay, so I get too much stuff. So inheritance is a good idea if you're going to do everything that the parent does. But if you're not, then it's going to make your life messy, right? You're going to get too much stuff, and then you have to keep on worrying what you're inheriting, how much you're inheriting, what you want to change, what you don't want. So the solution, this is called the strategy pattern. And the idea, okay, so let me just go back here. So, okay, so the problem of reusing code using inheritance is that inheritance is too strong. So it is highly coupled. So whatever the parent does, the child must do. And when the child wants to do something differently, then it is essentially fighting with itself, right? Because it's, because on one hand, when you inherit from something, you say, I am that, right? On the other hand, I'm saying, but I'm not completely like that. So you have to like, but you have to you have to like look for the things, ways you're different. No, let's say you only need one thing from an object and the object does 100 things, you're getting everything, right? But the better way would be just to take what you need, right? Right. So if I need something, I could just take what I need and use that rather than take everything inside that object. And then I get stuck with worrying about what I do differently than the other object. Okay. I don't want to get stuck with that. So itself. Okay. So that would be the problem. Okay, so the solution, okay, and then number three, as we spoke about, is the fragile base class, right? Which is basically, I remember I was speaking about that, where I work, where everybody is scared to make a change because in the parent class, because that's like really scary, because you don't know what, right? Like, for example, over here, if we make a change in duck, how it flies, we don't know what's going to happen to all these other ducks, right? Could you tell? But if I change this, which objects are going to be affected? There's no way of knowing, right? You have to actually go through every single one and see what they do and see how changing this affects this, right? Because some of them use it, some of them change it, some of them don't change it, right? Right. So for example, I forgot which ones do what, do which. So it gets very, very complicated. And we only did this in 10 minutes. Can you imagine classes that have been going on in a company where people write code, you have like 5 people or maybe 20 people in the group writing code 8 hours a day. Can you imagine how much code is going to be inherited and how much code could get messed up when you change a parent class? So that's called they have a name for that even. They call it the fragile base class. Okay, that basically when you use inheritance, the parent class, if that changes, it's very hard to know what you messed up. You have to like test everything, and you still might not be able to catch all the bad things that could happen. Okay. Um, okay, so we'll okay, so I guess we'll end here today, and then on and then we'll show using composition, right? Rather than inheritance, is that there's a much nicer way of doing it called this, and it's called the strategy pattern. Okay, okay, so this is the problem, and then we're going to do the solution on we'll do that on Tuesday, okay? We'll do the stretch because it's a whole thing. Okay, so have a good weekend and okay, I'll see you. Okay, any questions, by the way? Okay, any questions, just send me an email. I look at my email every morning. Okay, in fact, I just remembered I had an email I have to answer. Okay, everyone have a good weekend.